Hey everyone, Sarah here with the next topic in our Fusion Fundamentals series, which will be all about the different compilation strategies used in DBT. We've already talked about how the DBT Fusion engine can detect issues with your SQL before it's run because it analyzes the code during compilation. This time we're going to shift gears to talk about when DBT does the work of compiling your project, because Fusion didn't just introduce new steps in the process, but it totally changed how compilation is even ordered. So let's start with how DBT Core works. When you run something like DBT Build in DBT Core, models are rendered one at a time right before execution. So Core takes a model, renders the Jinja, produces a SQL string, sends it off to the warehouse, waits for results, and then moves on to the next model. We call this just-in-time rendering. It's simple, it's predictable, but it also means that rendering and execution are tightly coupled. And DBT Core needs to do this because the only time that it knows it's safe to render the next model in the DAG is when the previous model has completed successfully. Problems like missing columns, invalid refs, or misused functions only surface when DBT Core sends that model to the warehouse and begins executing. As a result, errors tend to appear mid-run, which can lead to wasted resources and leave your warehouse in an indeterminate state. So while this is not inherently a problem with just-in-time rendering, in practice, this means that many of your project's errors are discovered halfway through a run and not before. Fusion also has render and execution as steps in their workflow, but remember, it also has some intermediary steps, producing a logical plan and validating that plan with static analysis. For the sake of walking through this in a more visual way, we're going to simplify it and label that step as analyze. There's also a difference in the sequence of when the steps happen. Fusion renders all models in the project, and then produces and statically analyzes every model's logical plan so all of the SQL is validated. And only then will it start running models in the warehouse. This is called ahead-of-time rendering, and it gives DBT something it never had before: a unified view of your compiled project prior to execution. And this is possible because Fusion is a real-time SQL compiler with level 1 and level 2 comprehension built in. So no surprises, no wasted warehouse compute, and no more build failed on model 42 of 100 type of energy during a run. Not all models behave the same though. Right? Some models depend on live data from the warehouse at compile time and use what we call introspective queries. Some examples of this are macros that use run query or get column values. Fusion can't pre-render those because their SQL literally depends on dynamic results. So Fusion does something kind of clever with these. Those models containing introspective queries and anything dependent on them downstream will automatically switch back to just-in-time rendering. Even in these scenarios, Fusion still performs static analysis on the models. These checks have the same rigor as ahead-of-time analysis. The difference is when they occur. Because the SQL must be resolved just in time, Fusion can no longer 100% guarantee alignment between what it analyzed earlier and what will ultimately be executed in the warehouse. For this reason, we classify this mode of static analysis as unsafe. But unsafe doesn't mean risky in the sense of skipping validation. Rather, it reflects that Fusion may only surface certain issues at execution time after some upstream models have already been materialized. It will still catch the vast majority of SQL errors and prevent execution of invalid queries. It just might identify them later in the process. Dynamic models remain dynamic, and Fusion adapts to these conditions in real time. And while static analysis automatically does the sensible thing on your behalf, it's fully configurable if you want to customize any of the behavior. This shift underpins a ton of what makes Fusion feel fast, safe, and honestly, more modern. This compilation strategy is the foundation that enables real-time validation, better column-level lineage, smarter adapters, optimized compilation, and AI-ready data. If you want to learn more about this topic, I'll link some docs pages and developer blogs for you all to check out. And if you want to get hands-on and see what this change looks like firsthand, go install Fusion and take it for a test drive.